The system of linear equations has a unique solution. Find the solution using Gaussian elimination or Gauss-Jordan elimination. Now, if I use Gauss-Jordan elimination, Gaussian elimination is going to happen within it. So if I use Gauss-Jordan elimination, I can actually do both in the same video. So I'm going to use Gauss-Jordan elimination. And what that means is that I'm going to have a matrix that looks like this on the left-hand side, and the right-hand side is going to be numbers, and those numbers will be my x, y, and z. So we got to get this matrix to look like this. So first of all, we got to start off with our first matrix, which is just writing the coefficients of every variable. Coefficient of x is 1. The coefficient of y is 1. Coefficient of z is 6. And then we write a 3, and then 1, 1, 3, 3, 1, 2, 4, 7. Now that I have this matrix, I'm actually going to pull this up so we can get the room. So what I need to do is I need to get it into that form. So the idea is to get a 0 here, and then a 0 here, and then a 0 here. So we want to work our way from the bottom left up, and then this one. And then we're going to work with the 0 here, here, and here. So the first thing I need to make 0 is this bottom left one. So in order to do that, what I'm going to do is I'm going to take row 3, and I'm going to subtract it to row 2, and I'm going to replace that with row 3. So row 1 stays the same, so we get 1, 1, 6, 3. And then row 2 stays the same, so I get 1, 1, 3, 3. And now what I'm going to do is I'm going to take this row and subtract this row. So I have 1 minus 1, which is 0. That's what we want here. And then I'm going to go 2 minus 1, which is 1. And then I'm going to go 4 minus 3, which is 1. And then I'm going to do 7 minus 3, which is 4. Now, the next thing I'm going to do is I need to get a 0 here. So what I'm going to do is I'm going to take this row and subtract it from this row. So I'm going to take row 2 and subtract it to row 1 and then replace row 2 with that. So I end up getting row 1, which is the same, 1, 1, 6, 3. Subtract the other row, so I get 1 minus 1, which is 0. 1 minus 1, which is 0. 3 minus 6 is negative 3. And then 3 minus 3, which is 0. And then we get 0, 1, 1, 4. Now, if you notice, this row right here already has 2 zeros, and I wanted the 2 zeros to be down here. So what I'm going to do is I'm going to switch these 2 rows to make less work. So I am going to switch row 2 with row 3, which then gives me 1, 1, 6, 3, 0, 1, 1, 4, 0, 0, negative 3, 0. Now, I need to, so this needs to, so what we got is we have a 0, 0, 0. We got a 1, 1. I need this to be 1. So what I'm going to do is I'm now going to multiply my row 3 by negative 1/3. So then I get 1, 1, 6, 3, 0, 1, 1, 4, 0, 0, 1, 0. Now, if you're using Gaussian elimination, we're at this point. This is it. And so what I would do is I would turn this back into a system of equations. And then now it's a triangular system, which means I can backward substitute to get my answer. But I'm going to keep going and use Gauss-Jordan elimination. So what that means is that I need a 0 here, here, and here. So I'm going to start with a 0 here. So what I'm going to do is I'm going to take this row and subtract it, take this row and subtract it from this row and replace this row. So I'm going to do row 2, and I'm going to subtract it from row 3, and I'm going to replace that with row 2, which will give me the matrix 1, 1, 6, 3. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. And then 4 minus 0 is 4. And then this row stays the same. Now, what I'm going to do is I got this to be 0, so I'm going to make this a 0. So what I'm going to do is I'm going to take this row and I'm going to subtract it with 6 times this row. So I'm going to take row 1 and subtract it with 6 times row 3 and replace that with row 1. So what we get with that is this row minus 6 times this row. So 1 minus 6 times 0, which is 0. So 1 minus 0 is 1. And then you have 1 minus 6 times 0. Once again, that's 1. And then you got 6 minus 6 times 1, which is 6. So 6 minus 6 is 0. And then 3 minus 0 is 3. And then the rest is the same. Now the last thing I need to do is to get a 0 here. So I'm going to just take this row and subtract this row. So we're going to take row 1 and subtract it to row 2, which then will be replacing row 1. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. 3 minus 4 is negative 1. Then we have 0, 1, 0, 4, 0, 0, 1, 0. Now, since I use Gauss-Jordan elimination, which is my favorite, since this is in that form, and if I put it back into a system of equation, you get x minus 0y minus 0z equals negative 1. So x equals negative 1. So that means x equals negative 1, y equals 4, z equals 0. So my answer is going to be negative 1, 4, 0.